Assalamualaikum and good morning to Puan Shahida. So we are from group Byte Brigade. Would like to introduce to you about our takoyaki ordering system. My name is Nur Ali Munira, and in my group we do have Lisha Roshini, Kisha, Kayla, Shazno Aida, and Izati. So for now, I would like to introduce to you about our project. The takoyaki ordering system is a digital solution developed for this one vendor at our Sasana Niaga. So it is to streamline the ordering system, customization and payment process for takoyaki at UTEM. So this system addresses several challenges faced by both customer and staff, especially during peak hour. It will automate essential function such as order placement, where customer can easily customize their order, queue management to ensure order are processed in a correct sequence, and cashless payment. So with these features, the system significantly reduce order inaccuracies and waiting time. Additionally, the system provides real-time data and insight that help operators to understand customer preference, monitor demand pattern, and manage inventory more efficiently. This insight will not improve daily operation, but also allow the management to make informed decision about staffing, promotion, and menu offerings. So the takoyaki ordering system aims to deliver a seamless customer experience while helping takoyaki store to optimize its operation, particularly during busy period to ensure faster and more reliable service. So I think that's it all for the introduction. I would like to pass it to my friend to let you explore more about our system.
Next is problem statement. In the fast-paced environment of food services and campus retail, managing takoyaki order efficiently is crucial for meeting customer expectation and maintaining a competitive edge. Here are three potential problem statements for takoyaki ordering project. First is inefficiency in order management. The current manual ordering process at Sasana Niaga can lead to long wait times, especially during peak hours, making it difficult for staff to manage high volumes of customer effectively. Next is high potential for order errors. The lack of an automated order management system increases the likelihood of order inaccuracies, which can lead to customer dissatisfaction. Third is limited data insights for business optimization. Without a digital solution to capture order and sales data, Sasana Niaga lacks valuable insights into customer preferences and demand patterns. This makes it challenging to make data-driven decisions that could improve menu or offering, stock management, and staffing. Next is I move to objective. To effectively address the challenges identified in the takoyaki ordering system, this project aims to establish clear and actionable objectives. First one is enhances order management efficiency. To develop an automated takoyaki ordering system that will minimize the waiting time, especially during peak hours, by shortening the order and preparation time. Next is reduce order errors through automation. To implement an automated order management system that guarantees order accuracy from entry to preparation, thus reducing errors, this will optimize the usage of resources by minimizing waste and improve customer satisfaction by decreasing the number of wrong orders. Lastly, use data analytics for business optimization. To utilize data analytics into the takoyaki ordering system to record sales and order information in real time. Data-driven choices for menu improvement, inventory control, and ideal staffing will be made possible by the insights. This will give into customer preferences and demand patterns. Next.
So I'll be explaining about the enhanced entity relationship diagram, which is EERD, presented here. This which outlines the data model for our system, which is Takoyaki ordering system. This design is to manage customers, orders, inventory, and feedbacks. Let's explore each part in details. So at the center of the model is the user table, which stores all the details of all individuals using the systems. It also includes the attributes such as user ID, the primary key, name, email, phone number, and address. So this table will act as a superclass for two specialized user types, which is customer and staff. So for customers, it stores specific details, which include customer ID, which is the primary key, and loyalty points. So each customer is linked to a user ID from the user table. Next is the staff table. It's also stores specific details such as staff ID and their role. The staff members are also linked to the user table via user ID. Next is the order table. The order table tracks customer purchases, and it also includes order ID, which is a primary key, order date, total amount, and status. Each order is associated with one customer ID, and one staff. The foreign key is staff ID, and responsible for processing it. Next is from payment table. The payment table manages transaction details. It contains attributes such as payment ID, payment date, amount, and payment method. Each payment is linked to an order ID to ensure it corresponds to a specific order. After that, we also have menu item. The menu item table stores details about the items available for ordering. It includes attributes such as menu ID, menu name, description, price, and category. After that, we have order item. The order item table manages the relationship between orders and menu items. As you can see here, the attributes are order item ID, order ID, order item ID, order ID, menu ID, and quantity. Order item is a bridge table. So this table allows an order to include multiple items, and each item's quantity is recorded. Next, we have inventory table. The inventory table tracks stock levels and costs for the ingredients. For the attributes, we have inventory ID, which is the primary key, item name, stocks, and item price. Second last table, we have required ingredient. So for required ingredient tables, it links to the menu items to the ingredients they require. So we have ingredient ID, which is the primary key, menu ID, inventory ID, and ingredient quantity. This will ensure proper inventory management by tying ingredients to menu items. And last table is the customer feedback. The customer feedback table captures customer reviews. It contains attributes such as feedback ID, which is the primary key, customer ID, order ID, and feedback tags. This table will help link the feedback directly to the customers and their orders. So I will pass to the next member to explain more about our system.
Next, I will be explaining about the transaction pathway. The first pathway is customer place order between customer and order table. A customer can place orders and the order details are recorded in the database. The second pathway is add order items between order and order item. Each item in the order is added to the order item table, which links the order ID with menu item ID. The third pathway is staff handling inventory. For each menu item in the order, the stock of ingredients is reduced based on the required ingredients table. The fourth pathway is customer payment for order. When a customer complete payment for their orders, their payment details are recorded in the payment table. The fifth pathway is update order status. Staff members update order status when the order has been completed after successful payment. The last pathway is customer feedback between the table customer and customer feedback. After the order is completed, the customer can leave their feedback and it will be kept in the database. Next, I will pass it to Kisha.
Now I would like to present about the project scope. The scope of the takoyaki ordering system include database architecture, designing the database schema that outlines the relationships between various entities such as customers, staff, inventory, payment, and orders. Second is data management, implementing efficient process for retrieving, storing, and documenting orders to ensure accurate tracking of inventory and order movements from receipt to delivery. Next, user interface, developing intuitive interface for various users, including customers, store staff, and administrative to enable easy access to information and streamline operations. Next, reporting and analytics, integrating reporting tools to analyze order tracking flow, delivery performance, and resource utilization, supporting data-driven decision-making and ongoing improvement. Last is the system integration, ensuring compatibility and integration with existing systems such as inventory and order processing platforms to create a cohesive operational environment. Next, I would like to present about the fact-finding techniques. For this project, a combination of interviews and observation was chosen as the primary fact-finding techniques to gather requirements for the takoyaki ordering system. Interviews involve direct communication with stakeholders such as customers, kitchen staff, and managers to gain a deep understanding of their needs and challenges. Structured questions were used to ensure that key topics such as order management workflows, common issues, and desired features were covered. Open-ended questions allowed participants to share their experience and expectations, providing valuable qualitative data. Next is observation. Observation involved monitoring the daily operations of the takoyaki stall at Sasana Niaga within UTEM. This technique allowed the team to gather real-time insights into workflows, customer interactions, and challenges encountered during peak hours. Key observations included the time taken to process orders, the frequency of errors in manual order handling, and the effectiveness of the current queue management system.
Next. For this project, we have decided to use a relational database management system, or RDBMS for short, as the type of database management system. And RDBMS, it provides an organized way to store and manage data using structured tables, where relationships between entities or tables can be clearly established through keys such as primary keys and also foreign keys. It ensures consistency in the data and supports efficient data retrieval and management. And moreover, RDBMS, it utilizes structured query language, or SQL for short, which provides a powerful and standardized way to query and manipulate the data, making it a reliable choice for this type of system. And among the available options between MySQL, Oracle, and etc., MySQL was selected as the most suitable application for implementation because it is widely used among developers at all levels, from beginners to experts. It is an open source application backed by a variety of uh, sources, extensive free resources for troubleshooting and also learning. And it is also particularly popular for web-based applications due to its scalability, performance, and also ease of integration with other technologies. And these characteristics makes it an ideal choice for smaller systems, such as our system, the Takoyaki ordering system, where efficient and straightforward database management is required. And in addition to its technical strengths, MySQL is a more cost-effective alternative compared to other systems like Oracle. And as an open source application, it also offers significant savings while still delivering high performance and reliability, making it an excellent choice for projects with budget constraints. And by choosing MySQL, we ensure that the system for our project remains affordable without compromising on quality or even functionality. So moreover, it is still good to use while also maintaining costs in an effective way. And overall, the combination of its features, community support, and also cost effectiveness, it makes MySQL the perfect fit for this project. And that is all from